Hey guys, welcome to the level 2 probability paper from 2021. If you're joining us for the first time, the way this video works is that I go through each question and let you guys know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question and then try the question out by yourself. Unpause the video just to see how I go about answering the question. So without further ado, let's get started. And yes, that is the correct time. Question 1A, part 1, proportion of senior students drink coffee regularly. So proportion of senior students, altogether we have 300 senior students, and the ones that drink coffee regularly is 122. So the probability is going to be, probability of coffee is going to be 122 out of 300. So it's 122 out of 300. We have 0.4067, and this question is worth an achieved. Part 2 of this question. So part 2 of this question is we have what's the probability random selected from who has sleep issues. So sleep issues is 143. And also drinks coffee regularly. So from that 143, 68 drink coffee regularly. So probability of coffee, if they sleep, or given they sleep, given having sleep issues really, is going to be 68 out of 143. And we're going to put this in the calculator as well. So 68 over 143 is 0.4755. And this question is worth an achieved. So part 3 of this question, we have a claim by Jack, and then it's actually telling us explain Jack's reasoning and justify why he's wrong. So we have to look at the probabilities first. So if we look at it, I think what do we got? We notice that fewer of them drink coffee regularly. He claims that it is less likely for coffee drinkers. So first off, we are actually looking at coffee drinkers to have sleep issues. So that is going to be, coffee drinkers are 122, and that have sleep issues is going to be 68. So that's the first probability we're going to be writing. Probability with sleep issues given they take coffee. So this probability is 68 out of 122. Then those who don't drink coffee. So if you look at those who don't drink coffee and have sleep issues, so those who don't drink coffee is 178, but they also seem to have sleep issues, right? So that's going to be 75 there. So we're going to rewrite this as probability of sleep issues with no coffee. So if you look at this, we're going to have a probability of 75 over 178. Okay, so now we've got these two probabilities, and what we're going to do is we're going to actually put the two probabilities on top of each other. So we're going to put, to figure out what the risk is, so we're going to put 68 out of 122 is equal to that's going to be 0.5574, and then 75 divided by 178 is 0.4213. Okay, so now that we've got the two, you can see that the probability with coffee drinkers given sleep issues is actually higher, but he actually claims that it is lower. So if we actually work out the relative risk, so relative risk of this is going to be 0.5574 divided by 0.4213. 0.4213, calculator, by 4213. We've got a risk of about 1.3230. So I mean, with the probabilities, you can actually see that probability of sleep issues given coffee is actually higher. It's actually more likely compared with probability of sleep issues with no coffee. And I guess the reason he might be thinking is he might be actually looking at the number of people. So if you look at it, he is actually looking at the number of people, because when you look at 75 and 68, you automatically assume that the 75 is higher, therefore it means that people that have sleep issues given coffee is going to be less likely. And I think he's looking at the number, and what he should be doing is, instead of looking at the number, he should be looking at the proportions. That's what he needs to be doing, and that's our justification for this question. So I'm just going to write a quick statement. So just kind of whatever I just said, just writing that as a statement. I'm just going to say that Jack is looking at the numbers: 68 having sleep issues with coffee, and 75 having sleep issues without coffee regularly. So he should be looking at the probability or the risks and not the number as well, and that's why his claim is incorrect. Now, grades wise, one correct conditional probability is worth unachieved. So if you were to do one of these two probabilities, you're going to get achieved. For merit, you're looking at two conditional probabilities, which is, we've done that, and a valid brief discussion why he is actually incorrect. So this discussion here is actually worth a merit. Cool, next question. So with this question, what use of facts and information given in table 1 to complete the table below. So we have got energy drinks involved right now, and it says 36 students didn't drink coffee but did drink energy drinks. So that's the total number of students, which means we've actually got 36 here. So this is where 36 is going to end up with. Then we've got only 7 of these students who drank energy drinks but no coffee, had no sleep issues. So that's going to be this box here. Now we have a whole bunch of totals here, so I am going to work out each one of these totals. So the first total I'm going to work is this one here, where we're looking at having sleep issues and don't drink energy drinks. Sorry. So we've got 36 in total, and we've got 7 that's already used up. So 36 minus 7 is equal to 29. Then we've got to work out that bottom line. So I'm going to do, so I'll just write it down here. So this box here is going to be 143, take away 68, take away 29. 157, take away 54, take away 7. 300, take away 122, take away 36. So if we were to do that, so 143, take away 68, take away 29, that's going to be 46. 157, take away 54, take away 7 is 100. Oh, what did I miss? 54. Why did I put 54? Oh, 54. 157 minus 54, take away 7. 96. That looks a lot better. And then I could do this 300, take away 122, take away 36, or I could do 46 plus 96 to get 142. Because remember that we've actually got totals along the this part here is the totals, and then this part here is the totals. So once the table is completed, we are going to be getting an achieved grade for it. Next, we're looking at part 2 of this question. So part 2 of the question is asking, we've got 850 students who don't drink either coffee or energy drinks. So who don't drink coffee or energy drinks is this line here, which is 142. And the question is asking, how many would you expect it to have sleep issues? So sleep issues is going to be there, 46 out of 142. So probability of sleep issues if no coffee or energy drinks. Is then equal to 46 out of 142. Now that as a probability is 46 over 142, so what we have to do is 46 over 142 multiplied by 850 students is going to give us the actual number of students. So if that's the proportion, 46 out of 142 multiplied by 850, that's going to give us 275.35. And the one thing that I've noticed is that you've got to have your final answers with people as whole numbers. And I know that you could have written down 275 students. But the answer also accepts 276 students. But the key thing being, for a merit, you actually need a whole number as the answer, so you can't actually leave it as 275.35. So part 3 of this question is once again we've got to kind of compare two different proportions here. So looking at that first kind of line there, I'm gonna work with just gonna get rid of those highlighted parts from that first question. So if we look at it, it says New Zealand who drinks containing caffeine regularly. So caffeine drinks regularly, so that's both 122 and 36, is likely to have sleep related issues. So that's going to be 68 and 29 together as well. So that's the first probability as compared to those who don't consume drinks regularly. So for the second one, because again we've got who don't contain, well, that's literally what we just did in part 2, sleep issues if no coffee or energy drinks done. So that's this thing out of 46 out of 142. So if we look at the probability, and I know I'm gonna not like this, but it's alright, it's just annoying writing all of this. So we've got probability of sleep issues if drinks with caffeine is, so we've got 68 plus 29, and then that's divided by the total number of those students, which is 122 plus 36. So if we were to work this out in the calculator, so we've got 68 plus 29, 97. 97 is divided by 122 plus 36. So this now gives us a probability of 6139. And we already have the sleep issues when they don't have any coffee or energy drinks. That's basically just copying it from part 2 of this question. Let me just see if this works. So that is at 46 out of 142. So 46 out of 142 is 0.3239. Now it actually claims that it is nearly twice as likely. So then what we're going to do is we're going to work out the relative risk, which is 0.6139 divided by 0.3239. And what we have here is a relative risk of 1.89. Now, you know, it's close to 2, so you could kind of go two ways, because you can actually say, well, it's not actually 2, therefore it's not valid. You could actually say that, or you could actually say it is valid because 1.89 is actually really close to 2 as well. So whichever way you decide to go, you've got to explain why. So if you say it's valid, it's as it's close to 2, you could say it's not valid as not equal to 2. Because I'm talking about the 2 is because of it says twice as likely. So I mean, I wouldn't write that as it is. I'd probably write that as a full statement. I'd say something along the lines of like, yep, claim is valid because 1.89 is very close to 2. Or you could say, well, it's not valid because 1.89 is not actually 2. So getting up to here is going to get you a T1, which is an excellent. So correct probability if consumed, that's an achieved. So this part here is worth an achieved. Relative risk found is a merit. And then getting to this part is going to be E1. So it's actually a double excellence question, because what we still haven't done is discuss whether the school survey provides sufficient evidence to support the validity of the claim. So for validity of the claim, there is a few things that we could actually talk about. All right. So always the first bullet point is having a look at the number of students in this survey. And right at the beginning, they kind of mentioned that this survey only had about 300 students, and it's an online survey as well. So, you know, the first kind of bullet point that we're going to talk about is the fact that this is an online survey, and it's not really a good representation of all students. So that's the first thing I'm going to kind of write down. Online survey of 300 students at one school as well. So that's the other problem. At one school, not representative of all schools. The second bullet point that you can talk about is they've talked about caffeine here. Give me 1 second, I just want to research. Sorry, just kind of trying to have a look at where you can actually get caffeine hits from. And tea. Oh no, that's not. They don't actually talk about tea, but does tea have caffeine in it? Yes, it should. We've also got non-cola sodas, protein bars, decaf coffee, guarana, weight loss pills, migraine-related pain relievers, chocolate. So there we go. So I mean, at this point, you're only looking at coffee and energy drinks, but there are other sources of caffeine that could be coming in as well. So we can't really talk about that last table. If you look at that last table here, where it says they don't drink coffee or energy drinks, but they have sleep issues. You know, if they're like a chocolate addict, it's a very good chance that they're going to be awake that they're going to have sleep issues. So kind of mentioning that coffee and energy drinks aren't the only source of caffeine. I mean, you could actually add extra parts in there. Aren't the only source of caffeine. And in the answer schedule, they said like any other valid reason, so you can get a bit creative with your answers. But the important thing is that in the schedule, they basically said that to get an E2, the second grade, you only need one valid point. And the easy one always is to have a look at the actual survey. Where was the survey collected from? Because most of the time, well, this is the second paper that I'm doing, and what I found is like this whole not representative for the whole schools is coming into play, or like for the whole population comes into play. So keep that in mind, and that basically gets you an E2. And that's question 1 done. So with question 2, what I'm going to do is I will have to actually draw a probability tree, and I think drawing that tree is going to help you out a lot with these types of questions. So the first thing I'm going to do is I've got younger customers and older customers. So younger customers, I've got 40%, which means older customers is 0.6. 1/4 of the younger customers required alternative milk. So alternate milk, and then non-alternate, I guess you'd call it, or like a regular one, I guess. So 1/4, that's going to be 0.25. This is going to be 0.75. Alternate milk, I guess, well, it's not non-alternate milk, so we can actually say that's cow's milk. Now 80% of the older folks there ordered cow's milk, so that's going to be 0.8 and 0.2. Of the younger customers who ordered a coffee with alternate milk, 15% ordered soy milk, so this is going to be soy, this is going to be not soy, so that's 0.15 and 0.85. And then half of the older customers who ordered alternate milk ordered soy milk, so then soy milk, non-soy, that's going to be 0.5 and 0.5. So this is the table that's going to kind of help me out for each of these questions. All right, so first off, looking at find the probability that a customer cafe is younger and orders a coffee with cow's milk. So younger and cow's milk is basically this branch here. So probability of young and cow's milk. Sorry, I know this is not the best of how to write these things, but I'm just trying to get the point across. So young and cow's milk is 0.4 times 0.75, and that is equal to 0.3. Now they do say tree is not required in the answer schedule, but like I said, if you draw the tree, it does help you see things a lot clearer. This question is actually worth an achieved. Then the second question, what we've got here is, so the second question is we are looking at find the probability that a chosen customer orders coffee with soy milk. So if you look at soy milk, that's young, alternate, soy. Then we've got older, alternate, and soy. So we can say that probability of soy milk is 0.4 times 0.25 times 0.15 plus 0.6 times 0.2 times 0.5. So put that straight in the calculator. 0.4, where's my calculator? 0.4 times 0.25 times 0.15 plus 0.6 times 0.2 times 0.5. Now that gives me a probability of 0.075. Now grades wise, correct probability added is a merit, and one of these probabilities correct is going to get you an achieved, which is either this one or this one is going to get an achieved. Okay, part 3 of this question. So part 3 of this question is actually connected to the previous question, because if you look at the question, it says what percentage order a coffee with soy milk, and we already have that from the previous question, because the previous question had probability of soy, which is 0.075. But we need to figure out what's the proportion that actually requires alternate milk. So that's 2 branches there. So we've got probability of alternate milk is 0.4 times 0.25 plus 0.6 times 0.2. So once again, working this probability out, I'm going to get 0.4 times 0.25 plus 0.6 times 0.2. That's going to give me 0.22. And what I'm looking for the probability is probability of soy if they from the probability of folks that have alternate milk. Now probability of soy is actually 0.075, and that's divided by probability of alternate milk, which is 0.22. So when we do this, we are going to get 0.3409, but it is asking what percentage order. Okay, so I mean I could write this as 34.09% or 34.1%, but the grade, the answer schedule does say that you can actually leave it as a probability. It does not have to be a percentage. So grades wise, we are looking at merit. Yep, that's merit for this question. And there's 0.22. If you find 0.22, you could get an achieved for this question. Yeah, all right, cool. So next question. So part 4 of this question, we're still going to be using the same probability tree. However, we've got a almond milk at the moment, which is 0.066. So what we have got here is we've actually got probability of almond milk. Now, we know that soy milk was at 0.15 and 0.5 for those two different branches, right? So basically what we have now is, I'm going to take out these other milks because we had soy here, we've got almond, and then we've got coconut. So we've got almond there, and then we've got coconut, and we've got almond there, and we've got coconut. Now I should probably put almond because there is another A there. So what we've been given is the probability of almond, which is actually this, basically this branch here. Now it also says that of those who were there were equal proportions of those ordering almond milk in each range. So that means we are going to call this equal proportion, we're going to put that as X. That means the proportion, that's going to be X, and this branch is also going to be X. So the first thing that we need to do is, if the question is asking how many times more likely is it for a customer to order a coffee, so we've actually got to figure out what those the rest of the probabilities are. And when I say the rest of the probabilities, we've got that coconut milk that we need to try and work out as well. So our first step is to figure out what that X is. Once we get what X is, then we can actually figure out this part here for coconut milk. So we could actually figure out those kind of branches there. And then we could compare it with cow. So the cow's milk part is coffee with cow's milk. Sorry, wrong color. Coffee with cow's milk is this one here. So it's that. So there's about 3 steps, four steps actually. It's quite a few steps to do, but let's actually figure out what that X value is. Now to look at the almond probability of almond, we've got 0.4 times 0.25 times X plus 0.6 times 0.2 times X, and all of this is equal to 0.066. So we're going to do 0.4 times 0.25, which equals to 0.1. So this is 0.1x plus 0.6 times 0.2, which equals to, that's not it, 0.6 times 0.2 equals to 0.12. So this is 0.12x, which equals to 0.066. Now 0.1 plus 0.12 equals 0.22. So this is 0.22x equals 0.066, and then x is equal to 0.066 divided by 0.22. So if I do that, I'm going to get x is equal to 0.066 divided by 0.22. That's going to give me 0.3. So what I've just figured out is that the x in red is equal to 0.3. So now I could actually figure out what the proportion of coconut is, because I could just go 1 minus 0.15 minus 0.3, and this part here for the coconut is going to be 0.55 because all branches have to add up to 1. So I've got 0.5 here, 0.3 there. I can do that 1 take away 0.5, 0.3. This is going to be 0.2. Okay, so now I've got to work out the green, the yellow branch, which is probability of cow's milk. So probability of cow's milk is 0.4 times 0.75 plus 0.6 times 0.8. 0.4 times 0.75 plus 0.6 times 0.8. That's going to give me 0.78. The next one I have to do is probability of, so sorry, just to kind of highlight, this is the yellow branch. Next I'm doing probability of cow's milk. I should have put cow there and coconut. That's actually cow, sorry, I didn't realize that there was 2 C's, that's my mistake. So probability of coconut milk is, I'm looking at the green line, which is going to be 0.4 times 0.25 times 0.55 plus 0.6 times 0.2 times 0.2. So this one here is coconut milk, which is the 2 coconut branches actually added up together. So putting that in the calculator, 0.4 times 0.25 times 0.55 plus 0.6 times 0.2 times 0.2, that's going to give me 0.079. Now it's asking me how likely it is for customer to order a coffee with cow's milk compared to coconut milk. So we're going to put relative risk, probability cows over coconut. So I'm going to get 0.78 divided by 0.079. And I'm getting a risk of 9.873. 9.873. So I can write a little statement that says, so my little statement there is going to be customers are 9.9 times more likely to order cow's milk than coconut milk. So bit of a long question, but I like these types of questions, right? Because it's like the answer just comes out clean. So grades wise, what we've got, correct probability of cow's milk, which is 0.78, could get you an achieved. Correct answer only for X with evidence of trial and error is achieved, so that's the X there. Or you could actually do a tree to set it up correctly, that could also get achieved as well. Now the achieved 0.3 is correct answer only, but if you show the working, then I think you're looking at a merit for it, the full working of it. Correct value T1, correct probability, oh wow, okay, but then excellence is if you get correct value of X and correct probability of coconut milk. So excellence is getting this and this, you're going to get an E1, and then relative risk calculated and probability compared is going to get you an E2. So you've got to calculate the relative risk and write a little statement to kind of guarantee that E2, which gives you a T2. Yeah, that's a pretty nice question actually. Okay, so All right, folks. So with this question, what we've got here is they've actually set up the probability tree for us. So all we got to do is fill up the probability branches, and then we should be good to go. So looking at the first thing, you can see that 30% of the time she orders a long black coffee. So that means 0.70 is flat white. Then we've got 40% with almond milk. That means 60% is going to be the other version, which is one of them available. Now it does say that when she does that almond milk with 40% and coconut milk, so this is almond and coconut available. If the cafe has both, she flips a coin to choose between almond and coconut. So that's going to be 0.5 and 0.5. As for the other option, when you look at non-alternative soy, so that's when only one of them is available, it is twice as likely to be almond as coconut milk. So twice as likely for almond is 2/3, and then for coconut is going to be 1/3. And now the question is actually asking, we're really just comparing three probabilities here, because the question is asking probability of long black, which is that, probability of almond flat white, so flat white almond is that, and then a coconut flat white. So with the coconut flat white, you've actually got two branches, right? Because you could have this branch here, or you could have the bottom branch there. So you're looking at three probabilities, kind of working them out. So probability of long black is fairly easy because that's just 0.3. Probability of almond flat white is 0.7. I just realized there is another almond flat white, because she could also do an almond flat white here with this branch. So we've got 0.7 times 0.4 times 0.5 plus 0.7 times 0.6 times 2/3. So doing this in the calculator, you get 0.7 times 0.4 times 0.5 plus 0.7 times 0.6 times 2/3. So this is going to give me 0.42 for almond flat white. So almond flat white is all the blue branches. So that's my first blue branch, and then this is my second blue branch. Then if you look at probability of coconut flat white, that is my two pink branches. I've got 0.7 times 0.4 times 0.5 plus 0.7 times 0.6 times 1/3. So these are the two pink branches there. Shall we be super? No, I typed in 0.4. That should have been 0.5 there. Apologies. Oh, that's just the same probabilities times 1/3. So I'm just going to be a bit lazy and just divide, take off this 2 and put that with 1/3. I'm going to get 0.28. Now the question is actually saying overall, is it more likely for Kathy to have long black, almond, or coconut? So we can actually say Kathy is more likely to have almond flat white, because that, yeah, because the probability of 0.42 is higher than all of the other three probabilities. Fantastic. So grades wise, either probability of almond or coconut milk flat white found is going to get you an achieved. So achieved is for either this or this, and you kind of need any justification for flat white found, milk found, correct conclusion. Justification could be as simple as circling the almond milk. Wow. Okay, so we've actually done that here, so the justification is worth merit. Cool. Let's go to the next question. I think that's question 2. Yes, it is. Question 2 is done. Alright guys, so question 3a, what we've got here is blah blah blah. We've got a mean of 7 and then we've got a standard deviation of 1.5, and we've been asked to figure out the probability of coffee, which is x less than 5. Now interestingly enough, you can kind of see that they say working on and or diagrams must be shown. So I'm going to draw a quick diagram first. So a quick diagram means that 7 is the mean, so that's going to be in the middle, and I'm looking for less than 5, and if I'm looking for the probability less than 5, I am actually looking for that part of the shaded area. So what I would also suggest you guys do is just to keep the examiner happy, like I would actually put the Z-score. Now I did see this question pop up in one of my previous videos where they said, how does what is the probability of z less than little z, like how did I actually come up with that? So remember that when it's x less than 5, we're with a mean of 7 and standard deviation of 1.5, but we need to find the z-score where the mean is 0 and standard deviation is 1. Now you are given this formula in your exam sheet. Let me just, so if you have a look at it, it's this formula right there, which is x minus mean over standard deviation. So we are basically going to use that formula to go x, so little z is equal to x minus mean over standard deviation. So x is 5 minus 7 over 1.5. And I'm just going to, look, the whole reason, I mean, I know we don't really need to do this, but just to be on the safe side, 5 minus 7 is negative 2, divided by 1.5 is negative 1.33. Alright, so in our calculators, what we're going to do is we're going to go into the, where was it? Stat mode, I think it is. Is it stat mode? Oh yeah, stat mode. And then distribution. Sorry, I don't, as you can see, I don't really use this a lot. So normal distribution is what we want, and we want NCD. And remember that the lower limit, we don't even know what the lower limit is, so I'm just going to put down as negative 999. The upper limit is going to be 5, standard deviation is 1.5, and the mean happens to be 7. And when I calculate this, I get a probability of x less than 5 is equal to 0.0912. And this gets me a grade of achieved. Cool. Next question. So the next question is, we've got 150 customers. Our mean is still the same. Our standard deviation is still the same, which is 1.5. And we want to find the probability between 8 to 10 first, and then we want to try and work out, multiply that by 150 to get the number of customers. So we are looking for a probability of 8x less than 10. So in a diagram, it's going to look like this, because we know that 7 is in the middle, and we've got 10, we've got 8. That does not look right. Tell you what, is way too early in the morning. Yeah, that's right. It's still 5:37. So I'm allowed to make those mistakes. So here we go. 8 and 10 is there. Is that right? Probability of 8 and 10, yes. So we are looking for this shaded region here. Now once again, I'm going to find out what if x is equal to 8, z is equal to 8 minus 7 divided by 1.5, and if x equals to 10, z is equal to 10 minus 7 divided by 1.5. Now in this case, 10 minus 7 is 3, 3 divided by 1.5 is 2, and then 1 divided by 1.5 is just 0.667. So we know that, I mean, I'm just putting it on the side there just to kind of show the marker that I know what I'm doing, but of course I'm actually going to use the calculator itself for this. So probability of 8 less than x less than 10 is equal to probability of 0.667 less than, I just forgot that less than there, sorry, less than 10. This time is going to be less than 2, And for this part, I am going to use the calculator. So 2 over 3, that does it nicely. And then I've got 2. Calculate the probability. Sorry, I just realized I've actually put the Z values. That was my mistake. I should have put the real values, which is 8 and 10, because that probability looked so wrong. 2297, that looks a lot better. Now going back to it, let's say you did put 2 over 3 and what was it, 2. Just remember that, like, when you're putting z-scores, your standard deviation is 1 and your mean is 0. Now if I do this, I should get 2297 as well, and as you guys can see, I am getting 2297, so either way that's fine. Now I've got 150 customers, so 150 times 0.2297. I find it frustrating that I've got to go out of this to do this whole thing. So 150 customers multiplied by 0.2297, that's going to give me 34.455. So I'm going to go with 34 customers. Now again, once again with the answers, they do accept 35 answers as well, so you're good to go with that. So correct probability, if you just write the correct answer of 34, I think it's an achieved. But if you do correct probability, which gives you an achieved, and then correct number of customers, must be whole numbers, gets you a merit. Right, next question here. Okay, so if you look at this question here, so we've got, firstly, I'm going to draw the diagram. So I've got 30% of the customers. This is 30% of the customers waited less than 5 minutes. So if I was to draw this, I know that the mean is still 7. And that's 5. So this is what that 30% is equal to. So that's going to be 0.3. Now if that's 0.3, what else do we have here? We've got to actually figure out what the standard deviation is. Calculate an estimated of standard deviation. Okay, so standard deviation is what we're looking for. So what we need to do is we actually need to figure out what's the z-score for 5. When it's actually not z-score for 5, what's the z-score for 0.3, if that makes sense. Because if you think about it like this, we've got the mean, which is 7, but you know how we say that z is equal to x minus the mean over standard deviation? Now we know that it's 0.3 is that green area, so we need to find what's the z-score, because we actually know what x is. X is actually 5, the mean is 7 divided by standard deviation. Now standard deviation is what we're looking for, but we need the z-score for it, and to get the z-score, what we're going to do is in our calculators, and hopefully I can do this right, because I always mess it up, because I just so much easier doing it on manual, and I'll show you guys how to do it manual as well. So if I go to norm, I'm looking for inverse n. So the tail is left, yep, that looks good, and the area, I'm going to put that as 0.3. And notice that the standard deviation is still 1 and the mean is 0, because I'm trying to find the z-score. If I'm ever trying to find z, I have to keep standard deviation as 1 and the mean as 0. Now I should get, theoretically I should get a negative answer, and I've got negative 0.2544. So basically the x value is 5, but the z value is negative 0.5244. How would I do this in the tables? Now in the tables, remember that the table only works, let me put it this way. So if this area is 0.3, this area is 0.2, and because it's symmetrical, what I'm going to do is I'm actually going to flip it like this, 0.2, and I'm going to find out what this point here is, because it's symmetrical, and then I can actually just make that negative, right? So I'm in the table, I'm looking for something that's actually close to 0.2. So if I go to the tables, and this is going to be extremely small, I can tell. 0.2, wherever that is. 1879 is there, 1915, 1995, 195. Okay, so here we go, right here. This is 0.1985, so that's 0.5, so that's my first decimal place. Then my second decimal place is 0.52, and I've got to add 15 to get to 0.2, and I don't have a 15. The closest one I have is 14, so I can see that it's 0.5, 2, and then I've got to add, so sorry guys, this is going to look a bit weird, but you kind of will understand what I'm trying to do here. Okay, so 0.5, that's the 1985. 0.52, sorry, is the 1985. Then I got to add 15 to the end to make it 0.2, and the closest one I have is 14, so you can see that it's 0.524. Yeah, as I told you, I do kind of prefer it that way, 0.524. Now in our calculator we've actually got 0.5244. Now remember that it does give it in the positive version, so you've got to actually put it minus because it's on the other side of the curve. Anyway, so we've got z is equal to negative 0.5244, so we can say negative 5244 is equal to 5 minus 7 and the standard deviation. So rearranging this, it's really weird because they've got a different answer in the schedule. So I've got 5 minus 7 divided by negative 0.5244, and standard deviation is equal to, maybe there was a typo, I don't know, let's have a look. 5 minus 7 is 2, so 2 divided by negative 0.5244. Now hang on, I'm not doing this right. You can't, I shouldn't have put a negative, I should have put a positive there. Well, you might be wondering, hang on. No, what am I doing? Jeez, that is negative. It's actually negative 2, not positive 2. Sorry about that. Like, look at that. Beautiful, beautiful mistakes. So that should be negative 2 divided by negative 0.5244, which actually gives me 3.814 minutes as my standard deviation. Okay, so do we actually agree with the manager's suggestion? Now look, what's happened here? Now if you look at the previous standard deviation, the previous standard deviation was 1.5? Yeah, it was 1.5. All right, so I want you guys to think about it like this, right? Like, and I know this, I might be wrong in this, you know, just put in the comment section if I am. But generally speaking, is like standard deviation is the amount of spread that you have. Now, what's happened is that when we looked at the first probability, so right here, all right, so the probability of someone actually waiting less than 5 minutes was 0.09. I'm going to kind of compare that to one probability of X less than 5 in the when the standard deviation was 1.5 was actually 0.09. So only 9% was actually waiting. And I guess the way I want you guys to think about it is that when the standard deviation was 0.5, the curve actually looked like this, like it's almost like squeezed in. But when the standard deviation was 3.8, the curve is actually more spread out. So if you think about it like this, here, if I put 5, 7, so in this one, we actually said that 30% were waiting less than 5 minutes. But when the standard deviation was 1.5, we was actually saying 9% were actually waiting less than 5 minutes. But if you look at the opposite side of it, because it's symmetrical, I could actually say 9% waited for more than 9 minutes. But in the when the special staff, this new staff member was put on, we can actually say 30% waited more than 9 minutes. So it's actually a much higher percentage of people that actually waited for more than 9 minutes. So you can kind of say that just because even though the cafe has like a standard deviation higher than the previous one as a whole, it also means that you're going to actually have the problem on the other side where 30% is going to actually wait for more than more than 9 minutes. So yeah, so based on that, I would actually kind of say that we probably shouldn't be rewarding this person because they've actually got a much longer wait time. The spread is much longer compared to the previous time when the spreads were actually a lot shorter. So just kind of adding that up, higher standard deviation means more variation and higher proportion of people waiting for under 5 minutes and over 9 minutes compared to before when it's only like 9% that were waiting under 5 and over 9 minutes. So theoretically should not be rewarded. Cool, let's go to the next question. All right, so with this question, we've got data from figure 1 and then we've got to do normal model. So I'm going to do median. We've got 50, so that's going to be between 25 and 26. Start counting from here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So that's going to be 6. Then we've got lower quartile, which is going to be the 13th number, and I think upper quartile is 38th number. So 13th number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's going to be 5. 38th number, it's going to be going 50 backwards. So 50, 49, 48, 47, 46, 45, 44, 43, 42, 41, 40, 39, 38. So that's 8.5. Interquartile range is 8.5. Take away 5, which is going to be 3.5. So that's the data from figure 1. Now, when we look at it as a normal model, we've got a mean of 7, standard deviation of 1.5. So with the median, well, that's kind of 50%, right? So if that's 7, we know that 50% is on the left-hand side and the right-hand side. So the median we're going to put as 7. Lower quartile is 0.25. So what lower quartile and upper quartile, what we could do is we could actually say that this area here is worth 50%. And so we could actually figure out what the two Z values, or we could actually figure out what the two X values are. Now, in the answer schedule, you do need evidence of it or quartiles found for normal model. But does it actually say evidence needed for part B? No, it doesn't. So I am going to go into menu, go into stat mode, distributions, normal, inverse normal. Now the tail is actually center. So center tail, and I'm going to go 0.5. Now I could actually put standard deviation of 1 and 0, which is going to give me my two Z values, which is negative 0.6745, positive 0.6745. But if I want the actual X values, then I'd put standard deviation as 1.5 and the mean as 7. And as you can see, I am getting 5.98 or 5.99 and 8.01. So lower quartile is at 5.99 and 8.01. Now, if I actually do interquartile range, which is 8.01, take away 5.99, that's going to give me 2.02. So grades wise, evidence of Z gets you an achieved, so that part gets you an achieved. Label sketched and indicated middle 50% can get you an achieved. Correct answer only can get you an achieved. I'm not sure what they mean by correct answer only, because if you look at this table here, they've got quartiles found for normal model is worth a merit, but I don't know how they would look at this correct answer only. So my recommendation would be to do all of this, which means you should be able to get a merit for that question. All right, so let's go to the next part of this question. All right, so for this question, we are looking at the center, we're looking at the spread, the shape, and everything like that. So one thing is that when we describe it, just describe it, we're going to be looking at merit for those things when we compare the center, spread, and shape. But whether you agree with it, whether it's actually whether you agree with the normal distribution model, that discussion is actually going to be worth an excellence. So let's get started. I'm gonna write down the bullet points first and then talk to you guys. So the first bullet point here that we're going to talk about is the center itself. Now if you look at the cafe data, that's actually 6. It's actually lower than the normal model median 7, so it does not actually fit. Now this statement here would be worth a merit, but the way we would change this from a merit to an excellence is by saying, where you might actually say a different model with a mean 6 might actually be better, because then you can kind of see that 50% is before 6 and 50% is after 6. So you can kind of say, okay, that's much better than using a model with 7 as its mean. Now, if you were to do this, then this statement gets upgraded to excellence. Now, you kind of need 2. You've got center, you've got spread and shape. So the next one we're going to look at is spread. So with the spread, you can actually talk about the IQR is much higher, suggesting data is more spread out for the data from the figure, which is 3.5 compared to the normal one, which is 2.02. And that's a merit. So to change this into excellence, our expected range is like, we do 3 times the standard deviation. So if you look at it, if you go 3 times 1.5, you're going to get plus or minus 4.5. And then 7 plus or minus 4.5 is 2.5 to 11.5. So that is where I'm going. The median is 7 plus 4.5, that's 11.5. 7 take away 4.5 is actually 2.5. But if you look at the data itself, the data is actually going from 1.5 to 15. So it kind of doesn't fit the model again. And so if we were to go with 1.5 to 15, what I would do is I'd go 15 take away 1.5. So that spread, the full spread, is about 13.5. Now remember, we're going 3 standard deviations from the median up and 3 standard deviations before the median. So we've actually got mean. So we've actually got 6 parts there. So if I divide this by 6, 13.5 divided by 6, it's going to give me a standard deviation of 2.25. So I might actually say standard deviation of 2.25 would be more suitable than 1.5. Because then that actually covers from 1.5 to 15. Then the next part we're going to be looking at is the shape. So by the way, that previous statement there should get you an excellence grade for it. Shape is that if you think about normal distribution, it's a bell curve, but if you look at this particular one, it's a bit early in the morning, mate. So you can actually see that the shape is actually not symmetrical. That's something to be mindful of, and I think that's it's got one little, I guess this, you can call it unimodal as well. And basically this part here, explaining this part, is going to get you a merit. And you can actually say that it is skewed to the right, this particular shape. So there is skewness to the right, it is skewed to right, and then there is 2 spikes at 5 and 7. 5 and 7 has peaks, and also unusual cluster at 15. Cool, and then that actually gets you an excellence grade as well. Now looking at the answer schedule, they actually say at least 2 valid comments comparing center, spread, shape. We did all of that, and it's really interesting because there is a note that says final statement on appropriateness of model not required, which I find it really weird, because they ask the question, is this assumption appropriate? But then in the answer schedule they say final statement is not actually required. And I guess partly because we are suggesting different things here. I mean, like, we're suggesting in the center, we're suggesting that the mean should be 6 for it to be a bit more appropriate. And for the spread as well, we're saying standard deviation should be 2.25 to be more appropriate. But when it comes to the shape, you can kind of tell that, normal distribution is probably not appropriate because of that big massive cluster at the end. And there is also this, it's got like a bimodal, because at 5 and 7 there is a bit of a spike actually happening. Cool. Is that it? Yes, that's it. 612, not bad. So that is it for this paper, folks. If you have any comments or any kind of suggestions, please leave it in the comment section below. I probably would have made a mistake somewhere. It's very possible. And thank you for all the feedback that I've been getting in terms of just having a go at this for the first time. I've had a couple of comments come through where they've suggested on things to make improvements in these videos. And that's the dog. He's come back from his bark. But yeah, so good luck for your exams. And remember, for normal distributions, always write the Z values just to keep that the marker happy. Yep. Oh, as I've said, good luck to you guys. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.